Good morning, guys. Welcome back. Today we are going to finish up chapter 5 with section 5.6, which is solving rational equations. So there's two ways we can solve these rational equations. One way is through cross multiplying, and then the other way will be very similar to what we were doing yesterday with the adding and subtracting with using an LCD. So to solve a rational equation, the first method, like I just mentioned here, would be using the cross products property, which is basically your cross multiplying, and then just continuing to solve for x, whatever you kind of end up with, you just go from there. If that method does not work for whatever reason, and I'll get more into those details in a minute, then you would have to multiply both sides by the LCD, which is kind of what we did at the end of yesterday's lesson. And then whatever we are resulting with, we just solve using our normal methods for solving, either getting x by itself or using quadratics if it's quadratic form, and from there. So what we're going to do is we will start out, and then also checking the solutions to eliminate any extraneous solutions, and those would be solutions that would give you something undefined, and I'll show you what that looks like as we go through. Okay, so first thing, as far as checking extraneous solutions is concerned, you would want to do that when you get your answers. You may have one answer, you may have two answers, depending on the problem. So what you would do is you'd plug that value that you got for x into the equation and make sure that it makes sense. So in this one, I would have -1 over 2 times -1 plus 1. And on the other side of the equal sign, I have 5 over 4 minus -1. So on the bottom here, 2 times -1 is -2. -2 plus 1 is -1. And then over here, 4 minus a negative would become addition. So basically you have 1 equals 1. So then you know that, yes, -1 is a solution. Now, if you were doing number 2 and you got the solution of 2, you would plug that in. So if I did 4 times 2 minus 3 over 2 minus 4 plus 1. And then on this side, I would have 2 over 2 minus 3. So when we simplify each of these, I get 8 minus 3, which is 5, 2 minus 4, which is -2. And on this side, I have 2 over -1. So when I simplify these, -2.5 plus 1 equals -2. So this is actually -1.5 equals -2, which obviously does not work. That does not make sense. So that would not be a solution for that problem. So as we go through, you're going to want to check your answers. It's going to become particularly important when you take your test because it's multiple choice. And, even though you might get, let's say, 2 for an answer on a problem like that, if you choose that one and not the one that says no solutions, you would not get credit. So be careful with that. Okay, so let's start by solving. Now, the directions here say solve the equation using the LCD. However, I'm going to do the cross multiplying method first because I think that's a little bit easier. The downside is you can't use it all of the time, but I think it's going to be probably wise to use it as your default method. Now, when you look at a problem like number 1, for example, you might say, well, how am I supposed to cross multiply? Because you have 2 fractions on the left here and only 1 on the right. So if you were going to cross multiply, you would have to get the 2 that have the common denominator on the same side. So actually, I think what I'm going to do is I'm going to skip ahead and I'm going to go to the regular cross multiplying first just to kind of refresh that, and then we'll go back to those. So I'm going to skip up through the notes to the second half. I like doing the cross multiplying first. Okay, so when you're cross multiplying, that's when you have 2 fractions, or in this case, rational expressions, with an equal sign in the middle. A lot of times people get confused and they think cross multiplying is just when you're multiplying 2 fractions, but it's not. It's when you have an equal sign in between the 2 different fractions or rational expressions. So in that case, you're going to take your numerator from the first one and your denominator from the second one, and you're going to multiply those, right? So -3 times, and anything that's a binomial or a trinomial would have to go in parentheses because that -3 is going to get distributed to that. Then you're going to cross multiply the denominator and the numerator from the other fraction. And on the other side of your equal sign, you will have 4 times x plus 1. So that's how you would do cross products property. Now you would just work it out. So we would want to get rid of our parentheses. So this is going to be negative 3x plus 3. And then on the right-hand side, we'd have 4x plus 4. Then we want to start combining like terms because we have x's that we want to get together. So I'm going to add my 3x over to the right-hand side, subtract my 4. So I'm going to end up with negative 1 equals 7x. And then when I divide, I'm going to get x equals negative 1/7. So it's going to look like that. Now, as far as checking our solution, this is where the calculator will come in pretty handy. So if I'm checking the solution on one side of my equation, I have negative 3 divided by, and then I have negative 1/7 plus 1. And this is kind of ugly with the fraction, which is why I'm going to do it on the calculator, negative 1/7 plus 1, and then I have to close out that denominator. So that side of my equation equals negative 3.5. So negative 3.5. And then on the other side of my equation, I'm going to do the 4 divided by, and then negative 1/7 minus 1, like that. And I also get negative 3.5. So I know that this solution is a legitimate solution. So now let's try number 2. So again, we want to cross multiply. So the numerator from one and the denominator from the other side are going to get multiplied together. So I'm going to have x times x minus 1 on one side of my equal sign. And then on my other side of the equal sign, I'm going to have the 2x plus 7 times the x plus 5. And because these are both binomials, they're both going to have to go in parentheses like that. Now, when you multiply binomials together, you're going to have to do FOILing, or using the distributive property. So on the left side here, I have x squared minus x. And then on the right side, I'm going to have 2x squared minus 10x plus 7x minus 35. Of course, at this point, we want to combine any like terms. So x squared minus x equals 2x squared, and these two here are going to give me negative 3x minus 35. Now, whenever you have an x squared and you're trying to solve the equation, you know that this is quadratic, so everything would have to go to one side, and you'd set it equal to 0 and use some of your quadratic strategies to solve it. So we're going to need to move over the x squared and the x using those inverse operations. So 2x squared minus x squared gives me x squared. Then when I add the x, negative 3x plus x is negative 2x, and then I still have that 35, and then that equals 0. So now at this point, you'd want to use any of your quadratic strategies. So for me, because I do not have a coefficient in front of my x squared, I usually find it the easiest to just factor. So the two numbers that multiply to 35 that subtract to get 2 would be 7 and 5. And since it's a negative 2, the bigger number gets the negative. This tells me that my solutions are x equals 7 and x equals negative 5. So now at this point, we need to check those two solutions. So I'm just going to check them on the calculator. So my problem here was x over 2x plus 7 on one side. So I'm going to see what that works out to be. And I'm going to check the 7 first. So if I have 7 divided by, and then I'm going to plug in 2 times 7 plus 7. That gives me, oops, hold on a second. see if I typed this in wrong. Yeah, let's see, I must have missed a parenthesis or something like that. So I'm going to put in the 7 for the x on the top. Then on the bottom, 2 times 7 is 14, and 14 plus 7 is 21. It's just easier, whoops, to do it in my head there. And then that's going to be 1/3, or 0.3 repeating. Now the fraction on the other side is the x plus 5 over x minus 1. So when I do that one, 7 minus 5 is 2, and 7 minus 1 is 6, and that is also going to be 0.3 repeating. So we know that this one works. The x equals 7 is definitely a solution. So now we want to try the -5. So I'm going to do -5 divided by, and then when I plug -5 in the bottom, 2 times -5 is -10. -10 plus 7 is -3. No, wait. -10, yeah. Okay. Then when I do the other side, I have the x minus 5 over x minus 1. I'm putting in -5. So I'll be -10 over -6. So if I were to do -10 divided by -6, I get 1.66 repeating as well. So we know both of those solutions are legitimate solutions, and neither one of them is extraneous. They would both be answers. So if this was a multiple choice question and A said 7 and B was x equals -5 and C was x equals 7 and x equals -5 and then D was no solution, obviously you'd have to pick the one that included both because they're both legitimate solutions. Okay, so moving on to the next page, we're going to do some more of the cross multiplying. Except there's a couple that it won't work for. So number 1 here will not work for cross multiplying because you have 3 different denominators. So this is an x minus 3. This denominator will be x plus 3x minus 3, and this is just a 1. So you'll have to use your LCD method here. So we're going to save that one for a little bit later. Now, on first glance, number 2, you might say, well, number 2 has 3 different denominators, but these two are the same. So remember, common denominators, fractions that have common denominators, can easily be combined by adding or subtracting them. So what we want to do is we want to get it so that there's just one fraction on either side of the equal sign. So we're going to take this one here, and we're going to move it over to the other side. So then we would have to subtract it. Because when we do that, we can then subtract these because they have common denominators. So now on the left, you're just going to have 2 over x minus 7. And then on the right, you're going to have -6 minus 9, which is -15, and it's over that common denominator of x plus 3. Once you do that, now you can just cross multiply it like we were doing on the last page, and you can multiply across. So you'll have 2 times parentheses x plus 3 on one side of your equal sign, and then you'll have -15 times x minus 7 on the other side of your equal sign. And then you'll just solve it like a normal equation at this point. So distributing to get rid of your parentheses. So that's going to give you 2x plus 6. And then here you're going to have -15x plus 7 times 15. Where are we? 7 times 15. Let's see, what is that? 105, I believe, right? Yes, 105. And then we're going to add the 15x over. So now I have 17x plus 6 equals 105. Subtracting the 6, that gives me 17x equals 99. And I'm dividing it, and I get x equals 99 over 17, which is an awkward answer, obviously. If you work it out on your calculator, you're going to get 5.8. So again, we want to check this answer to make sure it's not extraneous. It does look kind of like a weird answer. That doesn't mean that it's extraneous, but we want to plug it in. Now, when you go to plug it in, you could just put it into this one because we hadn't really solved anything at that point. We just kind of moved the equation around a little bit. So if I'm going to do this one, right, on the left-hand side, I have 2 over x minus 7. So 2 divided by parenthesis, then I have to put in my 99 over 17 there. So 99 over 17. And then I'm going to be subtracting 7 from that. So the left-hand side would give me negative 1.7. Now the right-hand side of my equation is negative 15 over x plus 3. So negative 15 divided by my x, which is 99 over 17 plus 3. And that also gives me negative 1.7. So this answer is a legitimate answer. It's not extraneous, so that would work. Okay, so let's move down to number 3. Now, number 3 is a little bit more of a straightforward cross multiplication problem because we just have one rational expression on either side. So we're just going to go right away with the cross multiplying. We don't have to worry about moving anything over. So we're just cross multiplying the two opposite sides. So on one side, we have 2 times x squared minus 3. And then on the other side of the equal sign, we're going to multiply the x plus 2 and the x minus 3. Now we're going to distribute to get rid of our parentheses. So we have 2x squared minus 6 on one side. And then on this side, we're going to do our foiling, x squared minus 3x plus 2x minus 6. And of course, those two like terms can be combined there. And that will give me negative x in the middle. So now again, when we have x squares, that tells us it's probably going to be a quadratic that we're going to have to solve. So everything needs to move to the same side. So when I move everything over, now it doesn't matter here which side you want to move it over to. Even though I have 3 terms on the right and 2 on the left, if I move my 2x squared over, it's going to give me a negative, and I just don't feel like dealing with that. So I'm actually going to move everything to the left so that my x squared can stay positive. So I'm going to subtract my x squared. I'm going to add my x and add my 6. So what's going to happen is I'm going to get x squared. The 6's cancel, so it's going to be x squared plus x equals 0. So now at that point, since I only have a binomial, I'm not going to factor it like the normal way, but I can take out a GCF of x, which leaves me with x plus 1. So each of these would be set equal to 0, so I'd have one solution of x equals 0. And then when I set x plus 1 equal to 0 and I solve it, using zero product property, I get x equals negative 1. So now I have 2 potential solutions here, and I would have to check them to see if they work. So, you can definitely still put them in the calculator, but if you'd rather just kind of check them on the paper, sometimes that works better for people. So like if I'm putting in a 0 up here, I would have 0, because 0 squared 0 minus 3 over 0 plus 2. And then 0 minus 3 over 2. So obviously we can see that that answer is going to work. Now if I want to check the negative 1, negative 1 squared is 1, and I have 1 minus 3. Negative 1 plus 2 would be 1. Negative 1 minus 3 would be negative 4 over 2. So this ends up being negative 2 over 1, and then of course negative 4 over 2 reduces to negative 2 over 1, so that also works out as a legitimate solution. Okay, so now when we go to number 4, this is one of those problems where there's 3 fractions, 2 are on one side of the equation, however, 2 of them have common denominators, so we can just move the one over and combine it with the other one with a common denominator. So I'm going to take my 8 over x plus 4 and move it over to the other side. Since it's currently an addition sign or a positive, I would have to subtract it when I bring it over here. So now on the left side of my equation, I have 10 over x minus 2. And on the right side, I'm going to combine these two. So 5 minus 8 is negative 3, and that's over that common denominator of x plus 4. And now at this point, I would want to cross multiply. And then we'll go from there, right? So when I cross multiply, I have 10 times x plus 4 on one side of my equal sign. And then I'm going to have negative 3 times x minus 2 on my other side. And then we're just going to distribute and solve. So when we distribute, 10x plus 40. And on this side, we got negative 3x plus 6. So now since we don't have any x squares, we don't have to worry about doing anything quadratic here. We're just going to get all the x's alone on one side. So I'm going to bring my 3x over here. And I'm going to move my 40 to the opposite side using my inverse operations. So I get 13x equals negative 34, right? And then I'm going to divide by 13. And this gives me some kind of crazy answers, little weird fraction here, negative 34 over 13. So now I want to test that, check it, right? So I'm just going to use my more simplified equation there. It's a little bit easier to check in that format. So when I go to my calculator, because I have to put this weird number in here, so I have 10 divided by, and then my x is the negative 34 over 13. And then I'm going to minus 2 from that. So that would be what that first half looks like. And I get negative 2.16 repeating. Then on the other side, I have negative 3 over x plus 4, and my x is this weird negative 34 divided by 13. And that is going to also be negative 2.1666, whatever. So we know that this is also a legitimate solution. All right, so 2 more for the cross multiplying. So 5, again, is another one of the straightforward types where we just have the one fraction on either side. So we don't have to worry about moving anything over. We're just going to multiply across that equal sign on the diagonal and set it up. So we have negative 2 times x plus 1 equals, and then we're going to have to multiply these two binomials by FOILing. So we have negative 2x minus 2. And then over here, when we FOIL, we get x squared minus 8x minus x plus 8. And of course, those like terms in the middle there give us a negative 9x. Now we have an x squared here, but we only have one of them. So we're going to move everything to the side with the x squared. So we're going to add this 2x and this 2 over to the other side. Make sure you're combining it with the other like terms that you have there. Whoops, that line was a little crooked. So we have now x squared minus 7x plus 10. So this would be a simple factoring problem. What numbers will multiply to get 10 and add up to 7, 5, and 2? And since it's a negative 7, they will both be negative. So then when we go to find our solutions for x and we use zero product property, we would get x equals 5 and x equals 2. And those are the two solutions that we're going to now want to check to see if they are extraneous or not. So if I want to put in, since these are not like weird fractions or anything, it's kind of easy to just sort of check in your head. So I'm going to check the 5 over here on this side. So if I put in a 5, 5 minus 1 would be 4. 5 minus 8 would be negative 3, and 5 plus 1 would be 6. And we'll notice that both of those would simplify to negative 1/2. So we know that the x equals 5, that answer works. Now we're going to check the 2. So if I put in my 2, 2 minus 1 is 1. 2 minus 8 is negative 6. 2 plus 1 is 3. And both of those would simplify to negative 2. So that answer also works. Okay, so now for number 6, again, there's basically 3 parts here, three expressions, but 2 of them have the same denominator. So those can be combined together just like we did on numbers 2 and 4. So I can take my 4 over x plus 2 and bring it over here. And I'm going to have to subtract it because you always have to do the inverse operation. Oh, wait a second. I just realized they're different signs. So never mind. This is not the same because that's a plus and that's a minus. So this is where we're going to have to do our LCD. So getting into our LCD, we're going to skip back to the beginning of the notes and I'll do some easier ones before we get into the harder ones. Okay, so let's go back. Why is my screen not going? Okay, so all the way back to the beginning where it says solve the equation using the LCD. So first I'm going to solve it with the cross products property that we were just doing, and then I'll solve it with LCD so you can see how it works both ways. Okay, so if we're looking at this one, okay, we have 2 denominators that are the same. So if I wanted to move my 4 over here, I would then have 5 over 2 equals, and then I'd have to subtract that 4x. So negative 11 minus 4 would be negative 15, and then it would be over that common denominator of x. Then I would cross multiply. So 5x equals negative 30. Divide by 5, x equals negative 6. Now, the LCD method, okay, which I'm going to do over here, kind of like what we finished our lesson yesterday. We were looking for those denominators. Remember, we had the fractions in the fraction, and we were just figuring out what is the LCD of the denominators, and we were distributing it to everything to cancel the fractions. It's the same idea. So if I have a 2 and an x, if I distribute my LCD, which is 2x, to the entire equation, all 3 terms there, when I multiply 2x to 4 over x, I get 8x over x, right? Because this is really 2x over 1. Then when I multiply 2x times 5, I get 10x over 2. Sorry. And then when I distribute it to the third one, I get negative 22x over x. But of course, and you could have done this in your head on the first step, these x's cancel. These x's cancel, and 10 divided by 2 is 5. So you really end up with 8 plus 5x equals negative 22. So you don't really need to write that first step down that I wrote. I'm just trying to write it to kind of explain where I was getting that from. Then once you're here, it's like a normal equation. You want to get the x by itself. So I'm going to subtract the 8. So I have 5x equals negative 30. Divide by 5. X equals negative 6. Just like that. Notice we got the same answer regardless of which method that I used. So now to check it, and of course I don't have to check it both ways. It's the same answer. If I were to check this though, 4 over negative 6 plus 5 over 2 equals negative 11 over negative 6. So really 4 over 6, that's simplifies to negative 2/3 plus 5 over 2, and then this would be positive 11 over 6. So you can do it on your calculator in your head if you're not sure. So negative 2/3 plus 5 over 2. So negative 2/3 plus 5 over 2 equals 1.83 repeating. Then is 11 over 6 equal to that same thing? 11 divided by 6 is also equal to that. So then we know that this answer is legitimate. Regardless of which method we use, we still check for the extraneous solution. But you can see like cross product property, I think is a little bit easier. And you can do it as long as you have no more than 2 different denominators. So for this type of problem, you could use either method, right? So number 2, we're going to do the same thing. I'll do it both ways. So again, we have 3 different terms or fractions or rational expressions here, but 2 of them do have that same denominator. So if I just subtract that 7 over x, here, then I have 3/4 equals 5 minus 7 is -2 over that common denominator of x. Then I just simply cross multiply. So 3x equals -8. Divide by 3, x equals -8 over 3. Now, if you're going to do the LCD method instead, I'm going to erase this. You would have to figure out what is my LCD. Well, your LCD, you only have the one constant and you have x's, so it's going to be 4x. And you would distribute that 4x to all three of your terms there. So when you multiply the 4x times the 7 over x, you get 28x over x, but of course those x's cancel and leave you with just 28. Then when you multiply the 4x times the 3/4, you get 12x over 4, but 12 over 4 simplifies to just 3x. So the way I think of that is the 4's are canceling, and it's just 3 times x. And then when you distribute the 4x to the 5 over x, you have 20x over x, but of course the x's cancel, and you're just left with 20. And then you just finish solving this like a normal equation, getting your x by itself. So we have 3x equals -8, divide by 3, and of course we get the same answer doing it this way, -8/3. And then if we want to plug that in and check it to make sure that it's not extraneous, if I plug it into the original one here, I'm going to have, where's my paper? So 7 over x, and we know that our x is currently -8/3. So that plus 3/4, that's the left side of the equation, would be -1.875. Then the right side of the equation is 5 divided by that -8/3. And that also gives me -1.875. So I know that this answer of -8/3 is the legitimate answer. All right, so let's do a little bit more practice with this LCD method. Now, right now, you might be thinking, why would I ever want to do the LCD method? The cross multiplying is definitely easier. So as you'll see on the next page, sometimes you have, unfortunately, no choice but to do the LCD method because you have more than 2 different denominators. So these two here, numbers 1 and 2, you could do with cross product property, right? Because you have x minus 3, x minus 3, or here you have x minus 2, x minus 2. So if you still want to do cross product property, that's fine. We're just going to take this over to this side here on the left. So it's going to become plus 2 over x minus 3, right? So 2 plus x, or x plus 2, over that common denominator of x minus 3. And then this side will just be 2 over 1. And then we cross multiply. So make sure you put those binomials in parentheses because we will distribute. Okay, so now when we distribute, we get 2x minus 6 equals x plus 2. Solve for x. So we're going to get the x on one side, the constants on the other side, so we end up with x equals 8. Okay, when we go to solve, or plug that in, I should say, to check to see if it's extraneous, it's going to work because if you put an 8 up here, so you would have 8 over 5, because 8 minus 3 is 5. And then over here you have 2 minus 2 over, and then 8 minus 3 is 5 again. So 8/5, that's what you're going to get if you do 2 minus 2/5. So that would make sense because 2 is really how many fifths? 10. So 10/5 minus 2/5 is 8/5. So we know that that's correct. All right, so number 2. Okay, so again, this one we have 2 different denominators. So the 2 that are alike, we can combine them on the same side of the equation. So we're going to have to subtract it this time because this is a plus sign. So 5x minus 10 but it's still going to go over that common denominator of x minus 2. And on the other side, we just have 7, so we're going to put it over a 1. Then we're going to cross multiply. So on the one side, I have 1 times 5x minus 10. You don't really need the 1. The other side, you're going to have 7 times x minus 2. Get rid of our parentheses. So 5x minus 10 equals 7x minus 14. We just distributed, right? Getting all our x's on one side of the equation, the constants on the other side. So now I have 4 equals 2x, divide by 2, x equals 2. If you want to plug it in and check it to see if it's extraneous, 5 times 2 is 10. 2 minus 2 is 0. On this side, we have 10 over 0. Now, when you have 0 underneath, what does that mean? That means it's undefined. So this means you actually have no solution. This is an extraneous solution because it gives you something that's undefined. Anything that's undefined is just going to make it a no solution. It's extraneous. So that's why it's important to check. Most of the time they work out, but you got about maybe 10% or so of them that will be no solution. Okay. All right, so number 4 we'll do, I think that's the last one here we can do with the cross product property. So we'll do that and then we'll start focusing a little more on the LCD. So for this one here, again, we've got 2 different denominators. We have the x plus 1 and just the plain old 1. So this one here, I'm going to move over. Since it was a subtraction, it's going to be added to the 5x. So we'll have 5x plus 5 over the common denominator of x plus 1. And on the other side, the equal sign is 4 over 1. Now we're cross multiplying. So 4 times x plus 1 on one side, 1 times 5x plus 5 on the other. And it doesn't matter which one's left and right. So now I get rid of my parentheses by using the distributive property. So 4x plus 4. And then over here, it's just going to be that 5x plus 5. Get all my x's on one side of the equation, my constants on the opposite side. So I end up here with x equals -1. So now let's check that to see if it is a legitimate solution or extraneous. So if I plug in my -1 up here, 5 times -1 is -5, but -1 plus 1 is 0, making that undefined. Then on the other side, I have a 5 over 0 again. So as soon as you see those undefined zeros there, you know that this is an extraneous solution, so there's really no solution to this problem. Okay, so we're pretty much done all the problems that we can do using the cross products property. So now we're kind of stuck using that LCD method that I showed you on the other page. So if you look, well, we're almost there actually. This one's a little bit different. So this problem, you might think, okay, well, there's x plus 2, a 2, and then this 5 is really over a 1. So that's 3 different, but 8 over 2 can actually be simplified to what? 4. And now I can just do what? Subtract the 4. So again, cross product property is definitely an easier method. So you want to use it whenever possible. So again, cross multiplying here, x plus 2 equals 8. Subtract the 2. So x equals 6. And then when I go to check it, 8 over 6 plus 2 is 8. And we already know that that's 4, and that's 5, and that's really a 1, and 1 plus 4 does equal 5. Okay, so now I think we finally have to do some LCDs. Okay, so as far as the LCD method is concerned, this is an example where we have 3 different denominators. There's no way of simplifying it, like 2/3 can't be simplified or anything like that, so we're kind of stuck with this LCD method that nobody really likes. So first figure out, well, what is the LCD? And you do that the same way we worked on yesterday's lesson with addition and subtraction. So first of all, when you have a binomial, remember that it stays as one term. You can't like take parts of it or anything like that. So we know that that's going to be part of our LCD. But the monomial terms, you can kind of like look and see what they have in common. So they both have a 3. So we know we're going to need a 3. The first one has an x, so we're going to have to include that. And then we're going to have to include that binomial term of x plus 6. And then what we're going to do is we're going to distribute that entire thing to this problem, all 3 terms like this. Now, as I showed you on the other page, you're multiplying that to the top, but then you're going to be able to cancel some of that denominator out. So when you're multiplying this term here, this LCD term, by each of these fractions, you want to cancel out whatever can be canceled. So you see how there's like a 3x on the top here, because that's getting multiplied to the numerator, but there's also a 3x on the bottom. So that's going to leave you with a 2 times x plus 6. Now we're going to go to the second one. Now this time, just the 3 can cancel out. So you're still left with the 2 that's here, and then you're still left with the x and the x plus 6 from that LCD. Now when you distribute this whole LCD to the third term, just the x plus 6's will cancel, so you're left with 8 times the 3x, which gives you 24x. So that's a little bit trickier, especially when your LCD is a little bit more complex. It's easy to miss something or, get a little bit tripped up on some of that. Once you get rid of all the fractions, now it's just solving a normal equation with parentheses. So we're going to get rid of our parentheses. So 2x plus 12. And here we have 2x squared plus 12x. Equals 24x. Because I see that I have a squared, this is quadratic, so everything is going to go to one side. So I know I have these two like terms. So I have 2x squared plus 14x plus 12. And then I also have to bring my 24x over to make it equal 0. So now it's 2x squared minus 10x plus 12 equals 0. Now this is where it can get a little bit dicey because you have to use your quadratics to solve it. Okay, now one option, you can use your graphing calculator to check this, which I would encourage. You could even do that first just to get the answers. So like if you were going to do this particular problem and you can go to your y equals and type in that 2x squared minus 10x plus 12 and graph it and look to see if you can find those x-intercepts. So it looks like it's 2 and 3. So if I go to my table to confirm that, I can see that the two answers or my zeros are 2 and 3. So you can do that as well. I mean, I can just go ahead and say, okay, I used my calculator and I got x equals 3 and x equals 2, right? If you weren't using the graphing calculator, you would have had to divide out a GCF of 2 and then factor this, and it would be x and x, the two numbers that multiply to 6 that add to 5 are 3 and 2, and they would have been negatives. And then you would have got x equals 3 and x equals 2. So the calculator is just a little way to kind of help you. Factoring is not really your forte. Plus, if the answers are not factorable, then it can help you that way as well. So now we want to check these to see if they're extraneous. So we have 3 and 2. So if I were to put in, for example, into this original equation, I'm just going to erase some of this so I can see what I'm doing here. So if I want to check the x equals 3, right? So I would have 2 over 9 plus 2 over 3, and then this would be 8 over 9. So 2/3 is really 6/9, and then that does look like it would work. So we know that the 3 works. So now let's check the 2. So if I have 3 times 2, that's 6. And then over here, 6 plus 2 is 8. And 2/6 plus 2/3. I feel like it's 6. Yeah. Well, 2/6 is really 1/3. So 1/3 plus 2/3 does equal 1. So that one is also a solution. All right, and then we're going to do one more LCD problem on this page. Okay, so this one's a little more complicated because it's one of the ones where we actually have to factor it out first. So we have this 3x over x plus 1. But on this side, this is really x plus 1, x minus 1. And then, of course, this is just 2 over 1. So we have to figure out the LCD here. And the LCD would be a 1, which we don't really need to write because it's not going to do anything. But then you need both of these two binomials as part of your LCD. So you're actually going to distribute x plus 1 and x minus 1 to the equation. So I'm going to distribute that whole thing, x plus 1, x minus 1, to all three of these terms here. So now when I multiply to the first one, obviously the x plus 1s would cancel, right? So I would have 3x times x minus 1. When I multiply to the second term here, right after the equal sign, both of the x plus 1 and x minus 1 will cancel, and I would just have 12. But when I multiply to the third term, I don't have anything in my denominator that's going to cancel, so it's going to be 2 times x plus 1 times x minus 1. So that's the hardest part about the LCD method, is figuring out what the LCD is and then correctly distributing it to the whole problem to cancel out all the fractions. If your fractions don't cancel out, then something's wrong. Okay, so now we're just distributing. So I have 3x squared minus 3x. And then over here, I have 2 times, and this is going to become x squared minus 1x plus 1x minus 1. Of course, those cancel. So now I can actually distribute my 2 to this part here. So I have plus 2x squared minus 2, and then 12 minus 2 is going to give me a 10. All right, and then the last thing I need to do, because this is quadratic, is get everything on one side of the equal sign. So I'm going to move that 2x squared over, combine it with that 3, subtract my 10 over. So I have x squared minus 3x minus 10 equals 0. So now you can factor this. You could also use the graphing calculator and see what those x-intercepts are if you're not really like a super big fan of factoring. The two numbers that multiply to get 10 and subtract to 3 are 5 and 2, but it's going to be a negative 5 and a positive 2 because of that negative 3, which means my solutions would be x equals 5 and x equals negative 2. Again, if you're using the graphing calculator for this type of problem, you could have put in that equation, that quadratic equation that we got, which was x squared minus 3x minus 10. Look for those x-intercepts. So you can see it negative 2 and then 1, 2, 3, 4, positive 5. You can check your chart to make sure that they are intercepts. So the negative 2 is right there, and then you have the positive 5, which is what we got for our two solutions. And if you want to double check to see that they're extraneous or not, 5 and negative 2. So if I put in 5, 3 times x would be 15. 5 plus 1 is 6. Then I have over here 5 plus 1, which would be 6. 5 minus 1 is 4, so that's 24 plus 2. So if you do this as a decimal, you get 2.5, and then this is 1/2 plus 2, which is also 2.5. So we know that that first answer definitely works, which was the x equals 5. So now we want to check the negative 2. So if I check my negative 2, 3 times negative 2 is negative 6. Negative 2 plus 1 is negative 1. Then negative 2 plus 1 is negative 1. Negative 2 minus 1, negative 3. When you multiply those together, you get 3, and then plus 2. So this is 4 plus 2, which is 6. And over here, you get a 6. So that one works as well. All right, and then we got, I think, 2 more LCD problems here, and then a couple word problems. So we're almost done, but I know this is a lot of practice. Obviously, if you understand it, you don't have to watch the whole video, but it just would help the more practice we get. Okay, so for this first problem here, we can see that there is 3 different denominators. This one here is a 1, right? And then this one is x plus 2 and x minus 2. So I'm just going to kind of factor that out to get it set up. Now, because we have 3 different denominators, we have to use LCD method for this problem. Our LCD here would be 1, which we don't really need to worry about, times the different binomials that we see, which are x minus 2 and x plus 2. So when we distribute that to the whole problem, it's going to cancel out these fractions, and we won't have any more fractions. So when we multiply this LCD to the first fraction, we end up with 3x minus 2 times x plus 2, because the x minus 2's would have canceled. Then when we multiply to this middle term, both of them cancel, so we just have 6. But when we multiply to the 1, nothing cancels, so we have x minus 2 and x plus 2, which you might remember is really x squared minus 4, right? So now we're going to FOIL over here. So we get 3x squared plus 6x minus 2x minus 4, like terms in the middle. So that's going to give me a 4x. And then over here, I have x squared and then the 6 minus 4, which is going to give me a 2. Then I got to bring everything to one side since it's quadratic. So I will have 2x squared plus 4x minus 6 equals 0. Now this is a GCF of 2. So I would divide out my GCF, and then I could factor this, x and x, positive 3, negative 1. And my solutions are negative 3 and positive 1. And you could also get those using your graphing calculator like I showed you before. And then if we want to check these to see if they are solutions, let's check the negative 3 first. Where does this want to go? Okay, so negative 3. 3 times negative 3 is negative 9. Minus 2 would be negative 11. And then negative 3 minus 2 is negative 5. And then over here, I would have negative 3 squared is 9. 9 minus 4 is 5. And then plus 1. So 11 over 5, which is really 2.2. And then over here, you have 1 plus 1.2, so that would also be 2.2. So that's going to work. So the first solution that we got does work. So now let's check the 1. So if I put in the 1, 3 times 1 is 3. 3 minus 2 is 1. 1 minus 2 is negative 1. 1 squared is 1. 1 minus 4 is negative 3. So this would be negative 1 equals negative 2 plus 1, which is also negative 1. So that works as well. So both of these are good solutions. Okay, so the last LCD problem here, similar to the other one. So x squared minus 16 is x plus 4, x minus 4. So we know that our LCD for this one is going to be that x minus 4 times x plus 4. So that's what we're going to distribute to this entire problem, right? This x minus 4, x plus 4. When we go to the first term, the x minus 4's cancel, so we're left with the 2x plus 1 times x plus 4. When we distribute to this one here, we just have 16 because the x plus 4 and the x minus 4 are both going to cancel with that denominator. And then we're going to have 3 times both x plus 4 and x minus 4, which if you just want to put it back into that x squared minus 16 form, save you a little bit of trouble there. So now we're foiling. So we have 2x squared plus 8x plus 1x plus 4. And then over here we have 3x squared minus 48. So we're going to combine any like terms we have. So we have a 9x here. And on this side we have 16 minus 48, which is negative 32, right? And then we want to get our x squareds all on one side. So I'm going to move everything to the right so I don't get a negative x squared. Okay. So I have x squared minus that 9x, and then 32 and 4 is minus 36. Now this one should factor nicely. The two numbers that multiply to 36 that subtract to get 9 are 12 and 3, and it's negative 12, positive 3. So I have x equals 12 and x equals negative 3. So if we want to check those two solutions, if I'm checking my 12, 2 times 12 is 24, plus 1 is 25, and then 12 minus 4 is 8. And then I would have 16 over 12 squared is 144 minus 16 is 128, right? And then plus 3. So if you want to figure that out on the calculator, 16 over 128 plus 3, 16 over 128 plus 3. So we got 3.125 on one side, and then 25 divided by 8, which is also going to equal that 3.125. So we know that the 12 works. Then if we want to try the negative 3, 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. Negative 3 minus 4 is negative 7. Negative 3 squared is 9. 9 minus 16 is negative 7. And then we have the plus 3. So 16 divided by negative 7 plus 3 gives us 0.714 on the one side. And then on the other side, we have negative, or 5/7. So 5 divided by 7, same thing. So that one works as well. All right, so hopefully you kind of get the gist of how to solve these rational equations, whether you're using the cross products property or the LCD method. So, you know, where is this kind of stuff even applicable to anything? So I'm going to just do a word problem with you here at the end just to kind of show you. I'm going to skip those last couple of problems. I think we've kind of beat this to death by now. So if we take a look at number 1, on the first 4 tests of the semester, your average is an 84%. You think you can score 96 on each of the remaining tests. How many scores of 96 would you need to bring your average up to a 90? Okay, so we know that when we find our average, right, we add up all the scores and we divide by however many there are. So far we have 4 scores at an 84. So you would multiply 4 times 84, right? Plus, you're going to get 96s on the remaining tests, and you don't know how many there will be, so we're going to make that X. And all of that's going to add up, right? Because you would add up all your test scores, and you would divide it by X plus 4. So X is how many tests you have left to take plus the 4 that you already took. Or you could write 4 plus X. But you want that average to be a 90. So you're just going to cross multiply. Put the 90 over 1, simplify this, and cross multiply. And that would be actually solving a rational expression. And this is like an actual situation that you would maybe come across, right? So 84 times 4 is 336. And then we have 96x, and this is over x plus 4. And then we have our 90 over our 1. So now when we cross multiply, I'm going to do the 96x plus 336 on one side of the equal sign, and then you're going to do 90 times x plus 4 on the other side, which gives you 90x plus 360. And then now we would just solve for x. So subtracting the 90x, subtracting the 336. So you would end up with 6x equals 24, right? Divide by 6, x equals 4. So you would need 4 more tests at a score of 96% in order for your average to be a 90. Okay, and then the last one here, you invest $40,000 to start a nacho stand in a shopping mall. You can make each basket of nachos for 70 cents. How many baskets must you sell before your average cost per basket is $1.50? So again, when we talk about average, right, we're, adding things up and then we're going to divide by something, right? But basically what happens is you want to know, well, when is your cost going to equal your profit? So our cost is that $40,000 startup fee, right? Plus 70 cents per order of nachos. And our profit, so how many baskets must you sell before your average cost per basket is $1.50? I think they mean how much are you going to make. So you want to know, when is that going to equal the 150x? So we're going to subtract the 0.70, and that gives us 0.80, and then we would divide by 0.80, and we end up with x equals 50,000. All right, and that's it. Okay, so I know this lesson can be a little bit challenging, so I will be available for a meetup today and tomorrow. So that's Wednesday and Thursday at 1:30 p.m. It is optional, but if you have any questions or concerns on any of the things, actually, wait, these notes are Thursday. So Thursday, you can ask questions on any of those days. We will have a review for Friday, and then the test will be Monday, but I will post it a little bit earlier for people that want to get it over with. And that's it. But reach out if you have any questions or concerns or anything like that. And I hope you have a great rest of your day.